Hello, welcome back to A Software Engineer Plays, the YouTube channel where a software engineer plays through video games with coding elements and problem solving to teach you some of the elements of programming, really, through solving problems and looking at logic problems. We're back in Human Resource Machine today. I've taken quite a break, and I think I'm going to continue up this path before going back to the Prime Factory and trying to turn on that second light there. So level 35 here is called duplicate removal, which, if I had to guess what we're going to be doing, might be removing duplicates. Okay, so we're starting out getting fired. Just kidding. A note from the supervisor, she's out sick, but she says it's time to eliminate inefficiencies, and that's it. Okay, cool. Send everything from the inbox to the outbox. Unless you've seen the same value before, discard any duplicates. Okay, so in this case, we send B out and then E, and then since we've seen an E before, we would not send it out. So basically we need to keep a record of everything that we've sent out before. So, obviously want to start with an inbox, and let's copy to indirect this spot. So that should copy to 0. And I think we're going to want an iterator basically to step through everything to start with and see if we've used the letter before. So let's go ahead and set up an iterator. And that's actually going to be the start of every loop through the inbox. Where we're going to copy from our iterator, which will be spot 0. So if I set this up now, we're going to throw away the... That's no good. Okay. And that's fine. We'll fix that later. But that does, in fact, work. So, we'll move the inbox here. Just make sure that's working. And copy to 0. Okay, good. So, now what we want to do is basically loop through all of our spots here. And to do that, we will start with what's in the 0 index, and start comparing for 0, 1, 2, 3 all the way up until we hit nothing, which will be... I forget exactly how this game handles empty spaces, but we will deal with that when we get to it. So, we're also going to want to jump back up to the top here. Okay. Thinking about it now, we may also... And we'll do that later. Okay, so I'm thinking we're definitely going to want to keep a record of which spot we should be writing to, but if we do our loop properly, it should always be pointing to the next spot. So I think we're going to actually want a working spot. So I'm going to designate spot 12 here to be the working spot. And then we're going to want to go through... and we can't subtract... I think this is going to throw an error, because I don't think we can subtract from nothing. Yeah. So, what we could do is just populate everything with zeros. That would be probably pretty time-consuming, but it would definitely give us a way to check and see if we've reached the end, an end condition. So why don't we do that here? I'm going to set up a little loop to initialize everything up here. So we'll copy from 14 and copy to indirect 13. Then we will bump up 13, and then we will jump up to there, and we will want to stop. Eventually, this will loop until we get to a spot that doesn't exist anymore. So I think if it's 0, we can jump out here. Let's see. Bump up 13. That's never actually gonna be 0. It will only be 1 or... Well, it will be 0, but we need to pick it up first to find out, so... Let's copy from 13 just real fast, and if it's 0, we can jump out of our initialization loop there. So this should initialize everything to 0. Just kidding. Okay, this is in the wrong place. What's happening there is that this is going to make it 0 right away, and that's no good. But we're never actually going to hit 0 in this instance, so what we need to do instead is... Well, we'll figure it out here. This is fun, looping forever. So it becomes 13, then we make it 0, and then we bump it up. But because it becomes 1, it's never ever going to be 0. So instead, what can we do? What if we copy indirect? Would that work? Is that ever gonna hit? No, it's not gonna work. Oh, yeah, that's not great. Oh, well, we can't subtract numbers and letters anyway. So we need to rethink things, and I'm thinking... maybe we have enough spots here just to write out the entire message, and then we can, So I do want to copy from there and just set up an iterator. Then we will inbox, and we will copy to indirect 13 and bump up 13. Jump up to the top. So this should write out the entire message. And we're probably hitting error now. We don't hit an error, okay. Good. Are there always going to be 10 inputs? Maybe. I don't know if that's an assumption that we can make, but, okay, well, the first one we want to keep a record of it, so we'll copy it to indirect 13, and then we'll outbox it, and then we can inbox again. I want to bump up 13. And we want to... I think we want to also add another number here. Does that work? Yes, good. So we'll outbox it. Oh, well, okay, that's fine. Okay, so put a D in there, and then we'll outbox it. So now we're saying we write to position 1, and this is going to be our iterator to check through. So we're going to inbox. We want to write to what is stored in position 13 there. And now we want to iterate through the loop. Which in this case is, we'll start at, start at 0, which is stored in location 12. So we will be subtracting indirect 12. If it's 0, then we inbox again. And we have to have our stop condition, which will be if what's stored in 12 equals 13. That'll tell us that we're done. We'll figure that out here in a second. So that's our start. Now we inbox A, put it down, sub that. It's not 0. So we would then bump up what's stored in 12. And I think we'll need to copy from what's stored in 13. Alright, D's out, D's down, so we're subtracting what's stored in the 0 index here. We'll subtract B, get a 2. It's not 0, which means it's not a duplicate. Go ahead and bump up 12, get a 1, so we will copy from location 1 again, subtract what's in location 1 here, get a 0, and here's what's interesting is that we don't have any way to outbox right now, so this is the problem. Mixing the loops like this isn't going to work because this loop needs to be separate, I think. Does that make sense? We'll copy to... No. Well, no. What we really need to do at this point is we'll continue doing this, and if at any point it's 0, we will be done. And if no, that does work. We're okay here. So basically we need to add some additional checks in at this point. And the reason for that being we need to make sure that if 12 and 13 are equal, we jump out of this loop and we outbox what's in the last register, which is stored in position 13. So I'm going to go ahead and copy from 13 and subtract what's in 12, and if that is 0, we will be done. We will pick up what's stored in indirect 13 and outbox it. And then we can start again, jumping all the way up to here, I think. We may need to reset 12 to be 0, but let's see what happens. I suspect we've got some logic errors, but we'll figure it out. So A goes in, outbox it. Now we'll pick up the second A, put it down. We're going to subtract that. Now because it's 0, we do not outbox. We're just going to move to the next inbox. And already I see a problem that we have not incremented our counter. That might not actually be a problem. Now we've got B here. So it's not. We're going to copy from there, make a 1, bump up, go there, subtract it, we hit 0. So our additional logic here is not working, but it should work now. The only problem is we're all the way up here. So this is where we need to do the check after we bump up 12. So that's where we'll do that. Step through again, E goes out, we'll bring in a B, get a -3, we're going to bump it up, copy from there, outbox the B. Okay, so now we should get another B, and we've got a B, so we inbox the next letter, place it down, and we run into a problem because we're not indexing our counter. So every time we jump up, every time we inbox, we need to bump up our counter here. So I'm gonna put the bump up 13 down here, I think. Let's see what happens. Okay, inbox, bump up 13. Okay, so we have a problem. Our 13's not getting bumped up properly. So we'll put it before the inbox, and that should fix our problem. Okay, we're gonna bump up 13 now. Inbox the D, it's gonna go there. Jump there. Get a 0, so we're send out that D. Now we're gonna get another B, so what should happen, we're gonna put it in slot 2. And see, we're not resetting 12, so that's a problem. So we need to reset 12 every time we inbox another number 2. So I'm going to copy from 14 and copy to 12, which we don't really need to do up here, so I can get rid of this command and save a little bit of space. Alright, good. Good. We should send out an E now. Now we're going to pull up another E, place it in slot 2. So we're going to now start subtracting from 0. We get a 1. So we'll bump up 12, copy from our newest position again, and subtract to make sure that we're at the end. We're not at the end. We'll copy from there, and we will do our subtraction from slot 12. We do get a 0 at this point, so we are not going to output. We're going to move ahead, reset our counter, update our iterator, and keep on going. So he should step through all of the letters here as we go. He'll do the second E there. Now we get to the C, so we'll outbox it, and we'll get another letter. So this logic seems to be working. I'm going to let him run through and see if we get any error conditions towards the end. And looks like we are good. So this is not optimal. We did it in 22 commands and 243 steps. A couple things we can do, potentially to optimize this, is cut down on the number of slots that we use in memory. You notice as we run through this, every spot gets used, which is unnecessary, really, especially for duplicates. What we can do, instead of storing every letter, we can check to see if we have a letter already stored and then not place it. So let's go ahead and try and implement that pretty quickly here. So what we should get, and let's just step through until we get to that point. So here we go. We're going to pick up another letter now. It's going to be a C. So what we should do is, at this point, we can go ahead and step through again. We can create a working spot and step through and see if it's worth storing it. We'll incur a little bit of an extra check because it's going to have to step through everything, but we will not have to step through all of the points later on, so it should save us time in the long run, because we're going to do more iterations through smaller loops, which should overall save us time. So let's go ahead and see what we can do with this. Basically, we want to, instead of copying to indirect 13 right away, I'm going to copy to spot 11. And then we can step through everything that's already here. And if we ever get a 0, then we don't need to do anything else with it. And we can continue the logic as normal. So what I'm gonna do here now is, we don't want that additional copy too. We just want to, let's see what happens. Alright, so store it there. We're gonna subtract what's in 12. It's not 0. We're gonna bump up 12, 13. And then we're gonna outbox a what's in 13. So instead of outboxing at this point, we want to copy from what's stored in 11 to what's stored in 13. So we will copy from 11, copy to 13 indirect. I don't think we would then need this, and then we'll outbox it. So let's see what happens here. I'm not sure this is going to work on the first attempt. We'll copy that, paste it, and then outbox it. Now we'll get an A. So we will store it there, get a -1. And so the main problem here now is that we are not picking up, the new value every time. And let's step through that again so we can see where we go wrong. We have an A coming up here. So we're going to subtract what's in 12. It's not 0, so we're going to bump up 12. Copy from 13, subtract 12. We are at the end. So that means we are going to send out our A. And now we'll jump up here. We'll reset our counter. We're now working in the second slot. We pick up a D, so we're going to copy it to spot 11. And now we're going to subtract what's stored in 12. It's a -1, so we're going to bump up 12. Copy from 13, subtract it, it's not 0, so we're not done with our loop. So then we're going to copy from 13 and subtract, instead of subtracting what's in 12 here, or rather instead of copying from spot 13, we want to copy from spot 11. So that's where we're going wrong. Copy from spot 11, not even indirect. We will step through. A goes out, E goes out, B comes in. This is going to be interesting because we got 4 B's in a row here, so we're going to subtract that, bump it up, copy from 13 to make sure we're not done with our loop. We're not done with our loop. Get a B. It's a -3. Subtract 12, we're at 0, so now we're going to output our B and maintain a list here. And also, it's kind of fun, it's also in order of outbox, so we will now move on to the next B. And what should happen here is we will go through, and when we hit a 0 at this point, we will keep on going. And we'll need to make sure we don't bump up 13 in this case. So we may have one last logic error to fix, but we will see what happens. Now what's going to happen is we're going to get this 0, and that's the sign to stop. But we are bumping up 13, so it's going to run into issues. So we do not want to bump up 13 in this case. We only want to bump up 13 in the instance where we need to. And we need to when we outbox. So I'm actually going to move that right there. So that should now only ever increase our incrementer when we have need of it. So we're going to step on through. And we have an issue. Let's see what happened there. Okay, so this is our second letter. We're going to copy from 11. And we're subtracting what's stored in 12. How did that happen? Back it on up. Okay, inbox comes in. Copy it to spot 11. Subtract what's stored in 12. It's not 0. Bump up what's stored in 12. Copy from 13. Subtract 12. It is not 0. It's negative, and that's why we're having the problem. So, I mean, simplest case, maybe we just replace this with a jump if negative. We could also swap around our numbers, but... And in this case, our bump 13 is in the wrong place. As you see, we've now overwritten spot 0. So we'll move that up a little bit. Now we should get a negative number there, so we're at the end of our array. We'll bump up 13, we'll store it in the new spot, outbox it, and we'll start again. We're going to get a C here. Keep on going. We're at the end of the array, so we should get a negative number here. We do. Bump up 13, store it in 2, and we outbox it. Now we've got another new letter, so we should go and write this in spot 3. There it is. And now we get our first duplicate, so what should happen is we will get to looking at spot 3. There we go. So we're now looking here, we get a 0, so we're going to stop and go again, and we will be writing to spot 4 now. But we're also going to do the same thing there. We get an A, so we start again. And now we've got a new letter coming in, which is a D. So when we get to the end here, we're negative. We reach the end. We haven't found a duplicate. So we're going to bump up that 13, store the D in slot 4, and outbox it. So you can see this is a little bit faster because we're not having to go through all 10 letters every time, so we should, I don't know if we'll meet the goal, but we should be a lot faster. I think we ended up using one more command, and we are considerably faster, not as fast as we could be, so in the next video we will explore some other optimizations we can do here to make this even faster. But for now, I will say thank you very much for watching. This has been A Software Engineer Plays. If you enjoyed the content, please do like, subscribe, comment down below, and I hope you have a great day. I'll see you in the next video. Thanks. Bye.